Do you think that sugar and too much of it can actually kill brain cells over time?
All carbohydrates are sugars, and fructose itself has been shown to be neurotoxic in various different ways. Eventually, you will start damaging the brain to the point that you actually see atrophy and physical shrinkage. These brains look literally like an 80-year-old with Alzheimer's.
Dr. Anthony Chaffee is a brain expert who spent over 20 years researching what we eat. In this episode, he explains why the foods you think are healthy are actually killing your brain.
You eat breakfast carbs, some fruit juice and some fruit or whatever, you have 5 hours, you just shut down your bacterial immune system. Then at lunch, you have some more of this stuff. And then at dinner, you have more of this stuff. So basically, an entire day, your immune system is impaired. You don't need to eat 1 gram of glucose or fructose. You don't need a single gram. So who can do this in a healthy respect where it causes no damage? No one. It will cause damage.
Eating sugar isn't just making you overweight, it is literally the death sentence for your brain, starving your cells until your brain starts to shrink. As a health researcher, I've spent months looking for an expert who could explain this without the mainstream sugarcoating. And that's why I brought on Dr. Anthony Chaffee, who understands the exact mechanism behind sugar, insulin resistance, and disease. Today, you'll learn the exact 30-day timeline of what happens when you quit the sugar and why you should eat butter and tallow instead. So Dr. Chaffee, my first question, I want to start with something extreme. Do you think that sugar can actually cause early death?
Well, certainly if they eat enough of it, it can. And there's a lot of reasons for that. I mean, one of the leading causes of death and disease is type 2 diabetes, which is, you can sort of think of that as carbohydrate poisoning. You get excessive amounts of carbohydrates, and that causes spikes in your blood sugar. And that elevated blood sugar actually causes damage to your body called glycation. You get advanced glycation end products, AGEs, which they literally age you. They damage your arteries. They damage the blood supply to various organs. And then you can get elevated insulin in order to try to keep this down, to try to protect your body from this. And then eventually you might get insulin resistance, and elevated insulin can also cause disruptions in your physiology elsewhere. And then your body becomes overwhelmed by this either way, and then you can't generate enough insulin to actually protect from the elevated blood sugar, and then you start getting diabetes. And so then you get all the consequences of diabetes, such as kidney failure, adult onset blindness, amputations, Alzheimer's, these sorts of things. So that's a major, major, major cause of serious harm and death is diabetes, certainly. But long before you get diabetes, you're getting damage to your body. So it's just a matter of understanding that sugar and carbohydrates in excess to demand and beyond what our own body makes for us is detrimental. And so if you're having a little bit every now and then, is that going to be that harmful? Like, well, it's going to be harmful in the same way that, a couple cigarettes here and there or a couple glasses of alcohol here and there are going to be. Like, yes, it's going to be harmful, but will your body get over it? Yeah, probably. But if you're having that every single day and you're doing this over an ongoing period of time, you are going to get disease and early death, yes.
I wanted to ask a question around, because people associate with diabetes as well, but they associate too much sugar with weight gain. So don't eat too much sugar and try to lose weight. But just to focus on sugar and how that affects the brain itself, do you think that sugar and too much of it can actually kill brain cells over time?
Well, we have to differentiate what we mean by sugar as well. I mean, so all carbohydrates are sugars. But sugar, as we talk about it, would be like table sugar, which would be sucrose, which is half glucose, half fructose. And fructose itself has been shown, or at least suggested, to be neurotoxic in various different ways, toxic to our mitochondria all around our body, including our brain, which would be detrimental to our brain as well. And then long term, when you get you can get actually what's called insulin resistance of the brain, is now being called type 3 diabetes or Alzheimer's. And so you get to the point where the glucose can pass into the brain, still cause glycation, but insulin is not able to get in, it's not able to be utilized. And so now your brain can't run on that energy or on that glucose. And so if you're only providing your brain glucose and you're not providing ketones or fat, which your brain actually preferentially runs on, if you have fat and ketones available and you have glucose in abundance, your brain will only run on the fat and ketones until and unless you run out, and then will it start running on the glucose. There are some cells that still run on glucose, but the vast majority run on fat and ketones, and this is true in your brain and in the rest of your body. Things like red blood cells, which don't have mitochondria, they can't run on ketones or fat, because you have to have mitochondria to run on fat and ketones. So they have to run on glucose. Fine, but that's why we make glucose. That's why we have glucose. So when you're just eating carbohydrates in your body, and it raises your insulin, which makes you gain fat, because insulin is the fat storage hormone. That's also going to suppress and prevent lipolysis. You can't make ketones. You can't use fat for energy. And now your brain's only option is glucose. And that's why people think, oh, your brain's primary fuel source is glucose. Well, that's just because everyone eats a bunch of carbs, and that's what our brain's running on when you eat carbs, because it can't run it, because there's nothing else that it can run on. So the problem is that when you're doing that continuously, and then all of a sudden your brain starts developing insulin resistance, now you can't even get enough glucose in your brain. And then your brain cells do start dying, and your brain does start decaying, and does start getting worse as well, because it's just not able to get energy in there at all. And then we see this on PET scans. So it's a positron emission tomography, where we look for like cancers and things like that. You do this by giving someone an injection of radio-labeled glucose, and then you do a scan to see where that glucose has gone. And so normally the brain would pick up a lot of that glucose, but in Alzheimer's patients, we're actually seeing significantly reduced glucose uptake in the brain in those cases. So it is the case that eventually you will start damaging the brain, damaging the mitochondria, and eventually starving the brain of energy to the point that it actually starts dying and decaying, and you actually see atrophy and physical shrinkage in things like Alzheimer's.
I've got a weird question for you. So you mentioned sugar, specifically fructose. So if you think about somebody when they first get born, so they're alive, birth here, and then they die. From birth to death, who in that range can eat sugar?
Well, anyone who, doesn't like themselves, who has like a sort of a, self-hate sort of, sort of relationship. People that just don't understand. I mean, you could eat carbs, but from birth to death, from a very long, distant death, not just like you're going to die here. You don't need to eat 1 gram of glucose or fructose. You don't need a single gram. And so, who can eat that? I mean, anyone can eat it. Anyone can smoke and drink or do heroin. It doesn't mean it's good for them. So who can do this in a healthy respect where it causes no damage? No one. It will cause damage. Now, the people that it would benefit would be someone who's starving, and someone who's poor and destitute, or you're in somewhere you just don't have access. If you're in West Africa and you don't have access to meat because you're very poor, and the only thing you can live on is cassava and rice, eat the cassava and rice. But that doesn't mean that this is now somehow not harming you. It is harming you. It's also saving your life. So it's like medicine, where you take chemotherapy, where it starts killing cancer cells, but it's also killing you, and it's also damaging you, and you just hopefully kill the cancer before it kills you. So it's you get the bad with the good. So in certain circumstances and scenarios, it could be better to eat some carbs than to starve to death. But that doesn't mean that those carbs are not causing harm at the same time.
So I wanted to turn our attention to specific foods that people are eating. But when a baby is born, is breast milk got any sugar in it?
Yeah, it does. It specifically has lactose, though. And so the thing is that there's a fundamental difference between sucrose and lactose. They're all carbohydrates, and it all breaks down into sugar. But lactose is a combination of glucose and galactose. And galactose is actually known to help the generation of myelination in the brain. So when a child's brain is developing, they have the nerve body, that's the brain cell, and it has this long chain or wire that comes down. It's called the axon, and that propagates that signal. So this sends the signal, goes down that wire, and that communicates with other brain cells, muscle cells, and other cells in the body through various synapses. And so it sort of, this insulation is around that axon. It's called myelin. And so it's like insulating a wire, and that helps propagate that signal so that the signal fires faster. So it goes faster, up to like 200 meters per second. And if it's not myelinated, that signal goes a lot slower than that, still in fractions of a second, but appreciably lower. Like right now, I'm doing things, I'm moving my hands, it's all instant, right? Whereas if my nerves weren't myelinated, it'd be sort of a bit little all over the place. This is why you see kids and infants, you'd have them grab something, they're sort of, they're not as coordinated, can't just grab a pen, right? They wouldn't be able to do that. They wouldn't be able to throw that up and catch it, right? They don't have the coordination. They don't have that nerve signal firing at that speed. And that's because their nerves aren't completely myelinated yet. Their brain and nervous system isn't completely developed. And so the galactose helps speed up that process. You don't have to have galactose to myelinate your axons, but it helps, and it helps speed up that process. So that's really helpful when you have an infant that's trying to myelinate this massive nervous system, and that galactose can help speed that up. And that's something we see in all mammalian life during that time, is this a bit of galactose. But it can also increase insulin, increase hunger, and so then they're saying, "Ooh, I want more of this," right? So it gives them a healthy appetite, so they eat enough so that they can grow, because babies are vulnerable. So actually having a bit of bump in their insulin to drive that hunger signal and to force them to store fat and store energy so that they can grow. That's beneficial when you're tiny and you're trying to grow. And the other thing is that even though breast milk has lactose in it, and enough lactose that it would kick us out of ketosis, babies are still in ketosis. It's a lot easier for kids to be in ketosis. And so they're still running on fat, they're still burning fat, and they're still burning ketones. And there are studies that show that formula is not the same as breast milk from many different perspectives. You have way too much omega-6s. They don't have the right omega-6s or omega-3s. They have like plant versions of this, like ALA and LA instead of DHA and EPA. And in totally the wrong proportions, completely the wrong proportions. And instead of having predominantly lactose, they're putting in sucrose and things like that. It's all garbage. It's terrible, terrible stuff. And obviously, again, if you're dying and you don't have your milk in, you can't feed your baby, it's better than having your baby starve to death. However, it is definitely a poor option if you have other breast milk available. And so there are studies that show that babies that are being fed formula versus breastfeeding, much lower levels of ketones, much lower levels of ketones with the formula. So babies actually do have the ability to make ketones and be in ketosis, even though breast milk has lactose. Mothers who are pregnant, or soon-to-be mothers who are pregnant, it is much more easy for them to get into ketosis, especially in the third trimester, even when eating carbohydrates, because that's when the baby's brain is growing exponentially. And they need ketones. You need ketones for your brain to, A, have proper energy, but B, because they can actually reform into fatty acids and reconstitute into the building blocks and structural materials for the brain and myelin to grow. And so those ketones cross the placenta freely from the mother to the child. And then that helps a baby's brain grow, heal, grow and develop, and helps that myelination formation process happen as well. So so breast milk is there and does have carbohydrates, but breast milk is not, this is what we're meant to eat for the rest of our lives. No mammal drinks breast milk for its entire life. They drink breast milk early on in infancy, and then they're weaned onto whatever their mother's diet is, and then they eat that for the rest of their life, and that's what we should be doing too.
Let's talk about the sugars that adults are eating right now. Do you think bread, rice, and pasta is sugar?
Bread, rice, and pasta?
Yeah.
Yeah, it's all sugar. It's a carbohydrate. That's the definition in terms. So this is organic chemistry. Those are synonyms. Sugar and carbohydrates, those are synonymous. Those are the same thing. So a sugar is a carbohydrate. A carbohydrate is a sugar. Now there are simple sugars and complex sugars, but they're all sugars. So it's simple carbohydrates, complex carbohydrates. It's simple sugars, complex sugars. So it's the same thing. It's an interchangeable term.
And what about fruit? Bananas, apples, pears, berries, are they all sugars which have the same effect as sugar in the body?
Yeah. There's a lot of sugar in there, and it's fructose and glucose. So it's sucrose. That's the predominant form of carbohydrates and sugars that are in fruit. And again, it can be quite problematic. It can cause serious harm in your body, and especially mitochondrial health. It can damage your liver. It can turn into fatty droplets. You can get fatty liver from this as well. There's a lot of other things that cause peripheral insulin resistance, which we call type 2 diabetes, and metabolic syndrome, things like that. So it's a major driver of disease in excess, right? So you can have some of this when fruit is seasonal and local and you're starving. Is that going to be a benefit? Sure. In that instance, having five pieces of fruit a day, like we're recommended, even if you live in northern Scandinavia in the winter, that doesn't make any evolutionary or biological sense. I mean, because how were people getting fruit shipped over from Costa Rica 5,000 years ago in the middle of the Arctic in Siberia? I mean, there are people that were living there and thriving there. In fact, you had to thrive in those situations, because if you weren't thriving, you'd be dead. I mean, those are very harsh climates. You can't do anything except thrive or die. I mean, those are the two options. So yeah, fruit and berries have the exact same fructose and sucrose combination combined with glucose and fructose that table sugar does. I mean, we remember where we get table sugar from. Refined processed sugar. We refine it from plants. We refine it from sugar cane and from sugar beets and things like that. It's the exact same chemical. The argument you could make in things like fruit and berries is that they have some vitamins that may offset that, or at least be beneficial, so you get the good along with the bad. But sugar, it's the same chemical. It's exactly the same chemical. It's going to have the exact same chemical response in your body. It's just like, if you have cocaine, it's like, okay, that's cocaine. Well, what if I mix it with vitamin C? It's good then, right? It's fine, right? It's just like, well, the vitamin C is fine, but just mixing cocaine with vitamin C doesn't all of a sudden make the cocaine magically good for you. It's still cocaine. It's still going to have the effects in your body that cocaine has in your body. But now you're just mixing it with something else. I mean, if you ate a whole packet of sugar and then took a multivitamin, that doesn't, well, it's fine then. There's nothing else. I mean, that's the same thing. You're eating something else with that. That doesn't make the bad thing that you ate good.
Do you think that the increase in processed carbohydrates, like packaged food, is driving like brain rot, ADHD, can't focus, can't concentrate?
I think it's one of many, but yeah, I definitely think it's a contributing factor. And we did see a large spike in these conditions at the same time that the government recommendations, 1977 McGovern report, and then the official 1980 dietary guidelines changed. They started suggesting, back before that, it was about 50% of the American diet was calorie-wise was about 50% saturated fat, which is about the same as is in breast milk. And then they said, okay, keep that down, total fat, below 30%, saturated fat below 10%, and then increase carbohydrates even as much as 65% of total calories, right? So there's this massive, massive jump in the suggested caloric intake from carbohydrates. And since then, we started seeing massive, massive differences in our health with ADHD, with mental health issues, with different sorts of chronic diseases, diabetes, heart disease, cancer, obesity, certainly, all these other sorts of things. Now, other things changed at that time too. We reduced saturated fat and animal fat, and we replaced that with polyunsaturated fats, like from vegetable oils and seed oils. That increased by 3.5 times since 1980. And high fructose corn syrup also increased by 3.5 times. Sort of actually, a bit of that was a replacement because cane sugar was a bit more expensive. And so then they started using high fructose corn syrup more. So it wasn't like a one-to-one. They massively increased the amount of sugar that we consume generally, but also replaced a bit of the cane sugar with high fructose corn syrup. So high fructose corn syrup increased by 3.5 times as well. But then total carbohydrate intake massively increased also. And so there are a lot of other things that came on at the same time. So how much was caused by sugar, how much was caused by just general refined carbohydrates, and how much was caused by seed oils or the absence of meat, the absence of or the lowering of the B12 and the saturated fats and the DHA and EPA and all these other sorts of essential nutrients that we were missing from meat and animal fat. It's hard to say, but I definitely think it was a major contributing factor. And ketogenic diets have been used in mainstream medicine for literally hundreds of years, very effectively for things like diabetes, for things like epilepsy, for things like migraines, for weight loss, all these sorts of things. They've been used very, very broadly throughout the literature going back hundreds of years. And now we have literally thousands of randomized controlled trials in humans showing that ketogenic diets can improve many, many serious health outcomes, including ADHD, mental health issues, diabetes, obesity, Parkinson's, Alzheimer's, neurodegenerative diseases, and neurodevelopmental diseases as well. And so I think that there's definitely a major contribution to neurodegeneration and different mental health issues from just sugar and carbohydrates alone, evidenced by the fact that we have controlled trials showing that you can reverse major depression, anxiety, ADHD, OCD, bipolar, even schizophrenia by putting people on a high-fat, meat-based ketogenic diet. So I think that that's very clear by the evidence.
Okay, so let's talk about what happens when you quit the sugar and quit the carbohydrates over a 30-day timeline. What's going to happen in the first 24 hours to someone's brain and body if they quit all the sugar?
Well, if you cut out sugar, within the first 24 hours, your insulin is still going to be elevated, and so it's you might find that you're maybe a bit more tired, a bit more sluggish, and that usually goes away at the end of that 24 hours when your insulin comes down low enough that your body can actually start producing your own blood sugar and ketones as well. So you get into ketosis, and then you'll start feeling better. You'll have more mental energy, more mental clarity. We even see this in Alzheimer's patients that they start actually improving within a day or two. They actually start having better cognition. You can even see this by just giving them a ketone drink, and they're all of a sudden their brain runs on ketones because insulin and blood sugar is not able to be utilized by their brain. But ketones cross freely, they get picked up straight away. So even just giving them a ketogenic drink, they go, whoa, their brain starts working again as well. So you'll start seeing that by the end of that first 24 hours, that you start picking up mentally.
Do you think that in an Alzheimer's patient, so if some of their brain has kind of died a bit, by boosting your ketones and quitting the sugar, can that make those brain cells alive again and kind of working?
Well, once things are dead, they're generally dead, but it usually takes a lot for these things to die completely. And then the other cells that haven't died can usually pick up a lot of that slack. And a lot of the brain shrinkage coming down are not necessarily just the neurons that have been dying, but other sorts of cells and other sorts of things that have sort of started to shrink, like the myelin. If you start getting demyelination, like if your B12 is low, not even low on the reference range, but actually most of the reference range, sometimes even the whole reference range can actually be so low that you actually get demyelination because you don't have enough B12 to actually maintain the normal structures of the brain. And so that's a major, major issue, is not getting enough B12, especially during development. And we have so many hundreds of studies showing that if kids even have just lower levels of B12 just than their peers, not even in the sort of considered deficiency levels, they don't do as well. The ADHD levels or rates are higher, mental health issues are higher. They do worse in school on standardized tests. Even a study with women that were pregnant, they found that as women got lower B12 levels, even though they were still in normal levels, their kids did worse in school going forward over a decade. So the women that were in the bottom 10% of B12, their kids were actually scored the worst on math and language tests for the next 14 years that they were studied. That was the length of the test. So the entire time, those kids were doing worse than every other student when their moms had lower B12 than the other moms. Now, presumably that is a sign of what their diet from there would have been and what their kids' diet would have been as well. So maybe it's not just the B12 during pregnancy, but a continuation of a low B12 diet that also is going to be low in other animal source nutrition, because B12 only comes from animal sources, naturally. And so if you're low on B12, you're going to be low on all these other nutrients that only come from meat and animal fat as well. And most of those are really important and required for the brain. So if you have an Alzheimer's patient or you have a child who has a B12 deficiency or has some sort of neurodegenerative process, and you're able to reverse that and correct that, you can absolutely see a regrowth of their brain. And I could show you pictures of that, but if you wanted me to, but it's you see this in B12 deficiencies when normally when mothers are vegetarian or vegan, they don't get enough B12, so the kids can't get enough B12 even from breast milk, and their brain has severe atrophy. And there's crazy pictures where these brains look literally like an 80-year-old with Alzheimer's, but it's actually a 6-month-old little girl that has B12 deficiency. And then after daily B12 supplementation, after 4, 5 or 6 months, it's just massively improved. Not necessarily back to where they would have been, but much, much better. I mean, physically grew. We don't necessarily have any studies in adults showing that with Alzheimer's and things like that, but I have seen that anecdotally, that when people switch to a ketogenic carnivore diet, they cut out all the sugar. Now they're getting all the B12, D3, vitamin A, choline, creatine, carnitine, DHA, EPA, saturated fat, cholesterol that their brain requires. They can actually improve. And so I've patients with multiple sclerosis that have reversed and shrunk their lesions, which are, MS is a demyelinating disease. It damages the myelination around the axons. And normally we never see those regrow, but that's because most people are on a standard diet that is over 70% calories from plants, most of that from carbs, and you just simply don't have the requisite animal source nutrients that I just mentioned that you need to remyelinate your tissue. Whereas you put someone on a carnivore diet and you optimize their B12 and their D3 and all those other things, you actually could see that. And so I've seen patients shrink their lesions by 40, 50% within the first 6 months to a year by doing a carnivore diet. And so in some of those patients, they have actually noted that their lesions have been shrinking down. And the ones who have been doing this for multiple years, they have significant reduction in their lesions, even to the point of not really having any lesions anymore. And in one case, I was speaking to a patient, and he said that his neurologist said that he'd been doing this for 5 or 6 years now, and had massively improved, completely put in his primary progressive MS into remission, which is generally a fatal disorder. And his neurologist actually said that his lesions were basically completely gone. There's a bit of scar tissue, and that's it. And it was before he had massive burden of lesions. But he also said that it was reported on his MRI that his brain had grown 10% from his first initial MRI. And then his neurologist followed that up by saying, but that can't happen. Like, well, you literally just said it did happen, right? But of course, it doesn't happen in the normal day-to-day because no one's getting the proper nutrients that they need to regrow and rebuild their brain. So I think it's definitely possible. I think it's definitely plausible that you can actually regrow a lot of and repair a lot of the damage. I mean, I've seen a gentleman, Dave Mack, who's has his own channel. I'm sure you've spoken to him before. He had a stroke 30 years ago and had severe right-sided weakness to the point that he was limping around, having falls, really difficult time going up and down stairs. And 30 years later, normally it's like basically whatever improvement you get after a year or two, that's it. That's as good as you're ever going to get. 30 years later, he went on a ketogenic carnivore diet, and within 3 months, he wasn't limping anymore. And he had improved his strength up to about 80% of his left side. So it wasn't perfect. It wasn't 100%, but it was massively better than it was before, to the point that it didn't affect him anymore. He wasn't falling down. He wasn't tripping. He wasn't, limping and being obviously, crippled is probably the wrong word, but severely neurologically impaired, which is what he was, and he's not anymore. And so it's you can see massive improvements, and I've worked in neurosurgery for a number of years and seen so many amazing, miraculous recoveries like Dave Max and like that gentleman who grew 10%, recovered 10% of his brain volume after 4 or 5 years. I've just seen so many of these things so many times that nothing surprises me anymore as far as these recoveries, and especially neurologically. And I think that's a major thing because we are just not supplying our brain with the appropriate nutrients, and ketones and fat being some of those nutrients that are essential for optimal brain development and maintenance and function, and poisoning it. And we're eating a whole bunch of things like carbs and sugar that are going to actually be like syrup for your brain and just slow it down. So, of course, we're not seeing these amazing neurological recoveries because we're not doing the things that we need to in order to precipitate them.
I just had a thought around that because, quitting sugar is one thing, it's the poison, but you're also then feeding your brain and your body with the nutrients it needs, B12, vitamin D, all the things that you said. So people have to think like take away the crap and put in the things, meat and fat that we need to actually survive. Let's talk about the 7-day mark, what happens to the brain and the body after a week of quitting sugar and quitting the carbs.
Yeah, well, when after 7 days you're in deep ketosis, usually get there about after 72 hours, and so you're going to be making all the glucose and glycogen that you need. We have studies looking at this that even within a week, elite athletes are burning fat and ketones at over 90% VO2 max. So even at high intensity sort of exertion, they are burning fat and doing it quite effectively. And so you're going to you have full access to all of your fat, which is the main storage form. You have a very limited capacity on how much glycogen you can store in your body, up to 2,400 to 3,000 kilocalories a day. Whereas fat, you can balloon up to the size of a beach ball and just keep storing energy. So there's an unlimited supply amount of energy that you can store almost in fat tissue. Glycogen, it's very limited. That's because that's not our primary energy storage form. Fat is. And so having access to our primary energy storage form makes a lot of sense as being optimal and also what we're primarily designed to do. So after 7 days, you're touched into that. Now, you're not going to be fully keto adapted. You're not going to be fully fat adapted because you haven't been running on fats basically since you were an infant if you were breastfed. And so you have different mechanisms and machinery that utilize and run on fat for energy versus carbohydrates. And your body is nothing if it's not efficient. Nature is nothing if not efficient. And so if you have all these pathways up to run on fat and ketones and you're not running on fat and ketones, you're running on carbs, you're going to downregulate those receptors because it takes time, energy, and resources to keep those receptors running and functioning. And so you have to maintain these carbohydrate ones because those are the ones you're using. Okay. So there's an idea of fat adaptation and that takes longer than 7 days, but you'll be in deep ketosis. Now the insulin will be low enough that you'll start developing autophagy and you'll start breaking down these old precancerous cells and cancerous cells and old damaged mitochondria, and you'll start making new, better, nicer, faster cells. You'll trigger and stimulate stem cells, and you'll stimulate mitogenesis. So you're going to break down the old damaged mitochondria, and you're going to rebuild more new ones. So you're going to make more new, better mitochondria. So some people will just fast for 5 days every 3 months to get those effects of autophagy and then go back to whatever they're eating. Whereas if you just stay in ketosis and keep doing that, you'll actually continue that autophagy and mitophagy and that improvement of your cells at a cellular and subcellular level as well. And you'll just get better and better and better and better.
As we've discussed, quitting the sugars and the carbs is only the first step. Staying on track is where the real work begins. Now, whether you're low carb, keto, or full carnivore, you know that doing it alone can feel isolating and confusing. And that's why we created Go Carnivore. It's a sanctuary for those who need expert support without all the noise. We brought together a team of world-class experts and doctors, including Dr. Anthony Chaffee, to answer all of your toughest questions. Things like cholesterol, saturated fat, what about iodine, and why am I not losing weight on a carnivore lifestyle? Now, this is strictly a zero judgment zone hosted entirely off social media to keep your focus where it belongs, on your health. And to make the journey even easier, we've just launched our new custom meal planner. Whether your goal is deep healing or fat loss, it tailors everything to your specific preference. from keto and ketovore to strict carnivore. And it completely takes away the guesswork of what to buy and how much to eat to hit your goals. So there's no more stress, there's just results. So if you're ready to level up your metabolic health and meet me personally on a live coaching call, just head to gocarnivore.com right now. We offer exclusive discounts for our new members who want to simplify their lifestyle and join a thriving tribe. I'll put the link in the description of this episode. See you inside on the next meeting. Bloody fantastic. After 7 days, this is, after 7 days, that is incredible, the power of just changing your food. What about 30 days? What happens when you quit sugar and carbs?
Well, you're going to be much more fat adapted. You're going to go through much more autophagy and mitophagy. So now you're going to have much more healthy, new, vibrant cells and vibrant mitochondria. That continues on for another 2.5 years. And after about 3 months, some studies have shown that you'll have 4 times the number of mitochondria, and they're 4 times as effective because they're all new and shiny and ready to go. So after a month, you'll have significantly improved your mitochondrial health and function. And we'll have broken down a lot of these precancerous damaged cells as well, and cleaned out a lot of garbage out of your body. You can sort of think of it as a sort of a detoxing. Do a sugar fast and a detox fast and a fruit detox, whatever. You're actually adding in toxins and carbs and all that sort of stuff. A lot of those detoxes pepper in long periods of fasting along with a bunch of sugary drinks. And it's really that fasting period where they're not eating anything that they're going to get better. And also you're cutting out, I guess, other things like seed oils and other sorts of garbage. So it's better than what you were doing before, but it's certainly not as good as actually just getting proper nutrients. So yeah, you're going to get a lot of this other garbage out. You will start, most people will start losing weight at that point. Some people for metabolic issues or other sort of reasons, it may take longer before they start losing significant amounts of body fat. But most people will already have started to lose significant body fat. You're running on your body fat at that point too, so at least you have access to it. And your immune system will start increasing because carbohydrates can suppress the immune system for a number of different reasons. Your oral bacteria will be completely different. So usually people's gum disease has disappeared in that time. They stop getting cavities. That bacteria called Pseudomonas gingivalis that causes gum disease is a known cardiac risk factor. It damages your arteries. It can damage your brain. We're talking about the connection between carbohydrates and brain degeneration and brain disease. There's a study out of Stanford from Dr. Annalise Barron that showed that in core biopsies of people who died with Alzheimer's, that 96% of them had that Pseudomonas gingivalis bacteria in their brain, right? And that they checked that with glioblastoma brain tumors, which is the most common and unfortunately also the most aggressive form of primary brain cancer. And they found that in 89% of the tumors sampled, they had Pseudomonas gingivalis, this bacteria that just lives in the mouth, but every time you brush and floss your teeth, that actually gets into your bloodstream, it goes to your brain, it goes into your heart, it damages your immune system, it shuts down your viral immune system. And then carbohydrates, we've known from studies back in it was 1974, I believe, where they gave people carbohydrates, generally from simple sugars. The only thing that didn't seem to do this was starch. So starch seemed to be, didn't have this effect, but all the other sort of simple sugars and sucrose and fructose, even from fruit, like whole fruit or fruit juice, actually showed at 100 grams that actually shut down neutrophil function, which are your main cellular part of your immune system, fights bacteria, fights cancer, helps with wound healing, tissue repair, things like that. That suppressed their function for up to 5 hours after you had just 100 grams of carbs.
From fruit juice?
Fruit juice, yeah. And fruit itself, whole fruit. So just as you got up to 100 grams of carbohydrates from fruit juice or fruit, it shut down neutrophil function for 5 hours. And so people are eating fruit 3 times a day, 4 times a day, or eating carbs 3 times a day. So you eat breakfast carbs and a whole bunch of carbs and some fruit juice and some fruit or whatever, you have 5 hours, you just shut down your bacterial immune system. And after 5 hours, it was still only half effective at fighting bacteria. Then at lunch, you have some more of this stuff. And then at dinner, you have more of this stuff. So basically, an entire day, your immune system is impaired. And it's only for like a couple hours when you're sleeping before you get up and ruin it again that your immune system can actually function properly. So during this time, you're at 30 days, your immune system is working better, your body's working better, your brain's working better. You have ketones, usually people's brain fog are gone. You're fat adapted enough that usually athletes feel that they are actually feeling better and have more energy than when they started and were eating carbohydrates. And certainly there are studies that show that you get no drop off in performance after about that time, 4 to 6 weeks. But then after 3 months, people are actually showing that they had increased performance. They're doing better on long distance running, on sprinting, and on powerlifting tests. That was a McSweeney study from 2018. It actually showed that the ketogenic group after 3 months outperformed the carbohydrate groups in all of those 3 different aspects. And so the idea is, oh, well, you can't do high intensity exercise. You can't do, if you want to run a slow marathon, then you could, well, that's just someone who is ignorant of the literature and has never actually been an athlete to any great degree and tried this as an athlete. Because that's what the literature shows, is that actually when you're in ketosis, you get better performance. And I've lived that as an athlete. And so even if the study said something different, like, well, I know that that's wrong because I was a professional athlete on 0 carbs, and I've never performed better and had better energy than when I was not on carbs. So the fact that my experience is supported by the controlled literature in elite athletes, that makes sense to me. And so the other added benefit you'll have at a month, you're fat adapted, and so you can, or more fat adapted. It can take 6 months to get fully fat adapted. But when you're at that point, your performance is still at the same level, if not better than it was before, with the added benefit that now you're actually tapped into your fat stores. Because remember I said that depending on your body size, you may have 100 or 2,400 to 3,000 kilocalories of energy stored in your glycogen maximally if you're maximum carb loading in your muscles and your liver. But, you take someone who's, 65 kilos, 140 pounds, so small person compared to me, but 6% body fat, so very lean. They can only maximally store about 2,400 kilocalories, but that 6% body fat on that small, slender person actually has over 35,000 kilocalories of energy available to it. So that's over 15 times the amount of energy. So even that small, slender person, that fat far outweighs the amount of energy that they'll get from their glycogen. So they have the same performance, but they can just keep going, which the carb athlete has to keep sucking down gels and packets and Gatorade and all that sort of nonsense. And then if you're bigger than that, so I'm 110 kilos and, and depending on when I was at my playing weight, I was probably 110 kilos and 5 or 6% body fat. So I would have been, I'd have, 60,000, 70,000 kilocalories of energy available to me, even though I was very lean. So, you don't need to eat the day of, you don't need to eat the day before, you don't need to eat the week before, really. I mean, people think that I have to eat now or else I won't have energy for my exercise. That's not how the body works. Lions go a week without getting a kill. So what were they lying? What were they eating? They better go eat something so they can go find something to eat. That doesn't make sense, right? The energy that you have today to run your life and do your athletics did not come from breakfast. It did not come from lunch. It did not come from dinner. It came from what you ate 2 weeks ago and stored in your fat, unless you're eating carbs. And then all that stuff you ate 2 weeks ago or 3 weeks ago or 5 months ago is going to be stored in your fat, and you can't access it because the carbs shut down lipolysis and you can't access that energy anymore. And so you have to eat carbs. And so you have to have breakfast. You have to have lunch. You have to have drinks at halftime. You have to have orange slices. You have to eat all this garbage in order to perpetuate your energy, or else you're going to crash. And so you don't have that when you're in ketosis.
So what to eat? So we've quit the carbs, quit the sugars. I want to ask about fats, because how do you see the balance of saturated fat, monounsaturated fat, polyunsaturated fat when it comes to EPA and DHA?
So EPA and DHA are long chain fatty acids. They're very long chain fatty acids, 20 and 22 chain fatty acids. Quite often these can be monounsaturated, and you get like the plant versions like linoleic acid can be polyunsaturated. Every time unsaturated just means it has a double bond. So it's not all carbon molecules aren't saturated with hydrogens or something else that they're bonded to. So they might have a double bond. So that's an unsaturated fat. Mono means just one double bond. Poly means more than one double bond. So those double bonds are areas of weakness, and that stress or oxidization or something can damage that, and then you have something bond to it, and now it's a different molecule. Now it's not what you actually wanted to use it for. It can't be used in the normal way that you would use DHA or EPA or linoleic acid or alpha linoleic acid. And so it's very unstable, sort of outside of the tissue, right? So this is why whole foods are much better than supplements or refined foods like seed oils, like the oils that are in the nut or the seed or something like that is at least better than if you do that highly processed, rancid, nasty industrial seed oil cocktail that people have. It's called cooking oils. They're terrible. You should never cook with them. And so even then, it's at least better. It's not good, but it's better than if you get it from like a bottle. So whole foods are always going to be best. But when you're looking at animal fat, we think of that, that's saturated fat, that's all bad. You know that olive oil has similar amounts of saturated fat as beef tallow. So this is not as cut and dry as people think. Coconut oil has far more saturated fat than beef tallow. Butter is about 65% saturated fat, and coconut oil is about 95% saturated fat. So you can't just say, animal fat's bad because it has saturated fat. No, actually, there's a huge mix of very healthy saturated fats, and saturated fats don't cause disease. They don't cause heart disease. And one of the largest studies ever looked at this, systematic review, or also called an umbrella study, which is the tippy top of the pyramid of the evidence hierarchy, where it's a meta-analysis of meta-analyses of randomized controlled trials looking at the connection between saturated fat and cardiovascular disease. And they found there's absolutely no connection whatsoever between increased saturated fat consumption and cardiovascular disease of any form. And in fact, they found a protective mechanism between increased saturated fat and strokes. And so people had less strokes if they ate more saturated fat, and they had more strokes if they ate less saturated fat. And this was published in the top cardiology journal in the world, the Journal of the American College of Cardiology, in 2020. And that was by Dr. Astrup and his colleagues. Some of these were the top lipidologists in the world. Some of these people had been on the dietary guidelines committees, the U.S. dietary guideline committees, where they themselves had suggested and recommended less than 10% saturated fat consumption. And in this study, they say that's completely wrong. There should be no arbitrary upper limit on saturated fat. There is no upper limit on saturated fat. And so people get a bit confused by that, but it's important to remember. But also it's important to remember that there are plenty of monounsaturated fats, or even some polyunsaturated fats in healthy beef tallow. That yes, there is saturated fat, but there's also this other mix. So you need a constellation of these different sorts of fats. You want them in their fat matrix because, again, they're A, more stable, but B, they come with other things that are beneficial as well. As far as getting your DHA, EPA, you do have to think about that from like a sourcing perspective. Whereas if you're predominantly getting just like Safeway, Costco, Kohl's beef or lamb or whatever, those are generally going to be grain finished. And when animals are in a feedlot for up to 3 months, or after 3 months, it's typically don't have much in the way of omega-3s left. It's all predominantly omega-6s. Now, the caveat to that is that cows and sheep and ruminants can actually conjugate linoleic acid, those omega-6s that come from plants, and make CLA, conjugated linoleic acid, which actually is good for you. And so even though they're getting this sort of crappy linoleic acid and omega-6s, and yes, you are going to have more omega-6s, you're going to have less omega-3s, you're also going to get some of that CLA as well, or a lot of that CLA as well. So it's not as bad as some other sort of options, but you do want to think about where you're getting your DHA and EPA from. And so if you can't get grass-fed, finished, pasture-raised beef and lamb, maybe try to get grass-finished beef and lamb fat. You can get tallow or lamb fat that's been sort of just isolated. But you have to look for like a yellow tint. When we open up a human body, the fat's yellow. It's not white. And so fat on an animal should be yellow as well if it's healthy and if it has all the nutrients that it should have. And so in Australia and America and elsewhere, they can say something's grass-fed or even grass-finished, and maybe it's not. Maybe it's they've screwed around with it a bit, and they just sort of technically met the requirements to call it that, but it means something very different than what we are looking for. And so in Australia, you can say something's grass-fed, even if it's been in a feedlot up to 3 months. But 3 months and a day, then you have to say it's grain-finished, right? So people could be getting, oh, hey, grass-fed, but the fat is bleach white. It's probably not. And then it may not even say grass-fed or grain-fed or whatever, but the fat's like dark yellow. That probably is. And so you know maybe just grab that up. So that's a better indicator than a label. Now, if you know if you know the rancher and the butcher and they can source it properly, that's probably good. But it should have that yellow tint to it. It should be at least be a tinge to it. Deeper yellow fat is even better, and that's often from the older animals, and that's even more nutritious as well. But they're going to have more of that DHA and EPA as well. So grass-fed butter, grass-fed ghee, dark yellow sort of fat, grass-fed tallow, grass-fed lamb fat, those sorts of things with a yellow tint to it, or wild-caught fish, some sardines in water, things like that are going to be good. So mackerel is a good source of DHA and EPA as well. So those sorts of things. So I would definitely think about that as well, especially for kids. Supplements like the fish oil supplements aren't great. I mean, there are studies that show that taking supplements will increase your DHA and EPA levels in your bloodstream. But a lot of these things, because they're outside of the cellular matrix, they can get oxidized and rancid and just damaged because of the unsaturated sort of components. And so they're just unstable. Even the ones we want, like DHA and EPA, are unstable. And so it's sort of a mix. I mean, if you are going to get it, I would just throw it straight into the fridge and keep it as cool as possible. And then, but I would also seriously look at other sorts of examples of DHA and EPA from your food, like wild-caught fish or the appropriately fed beef and lamb.
Very interesting. So we do have to get a variation of fat, but it comes from whole foods, which you're saying. I want to ask, when you quit sugar and carbs and you eat healthy fats and like meat, how does your microbiome change?
Oh, well, yeah. Your microbiome just depends on what you eat. So whatever you eat, your microbiome is eating. And if you think about it, all animals have a microbiome and an oral biome. Like I said, our oral bacteria change dramatically when you drop carbohydrates and things like that. So now you don't have the bacteria that cause cavities, that make acid and burn holes in your teeth that we call cavities, or the ones that cause gum damage and gum disease like gingivitis. And so I think that's going to have a very real impact on your gut microbiome as well. Same thing. You're just changing your diet. That's going to change which bacteria are going to be able to thrive and survive. But also, I sort of think of the mouth as probably like a reservoir of probiotics, because every meal that you have, everything you eat, the bacteria in your mouth gets into the food that you're eating, and then you swallow, and then that bacteria can be sort of stuffed in the middle of that bolus of food, and some of that could get through. If you're just taking a probiotic pill or a drink, it's just going to die in your stomach acid. But if it's mixed up with food, this is why veterinarians tell you to open up the capsule of a probiotic for an animal, a dog or a cat, and sprinkle it on their food, and then mix it up together so that they can sort of eat that together and have a chance at least of getting down to their microbiome. I think that's happening every time you take a bite of food with your oral biome as well. So if you have carbohydrates and all these sort of nasty bacteria, you're going to be seeding nasty bacteria into your lower gut as well. Whereas if you're not doing that and you're eating what you're supposed to eat, you're going to cultivate the bacteria that you're supposed to have, and those are going to go down into your intestine as well. And then again, cultivate and support the bacteria you're supposed to have. All animals have an oral biome. All animals have a microbiome, and they support their health in various ways. But whatever they're eating, their natural diet, well, obviously this is co-evolution, co-development, that whatever they're eating, whatever their natural diet, that's going to bring about a specific set of bacteria. And so whatever bacteria that they're supposed to have should be supported and will be supported by the optimal food for that animal. So a hippo eating grasses and different sorts of vegetation, that's going to support the microbes in their gut that help them. And us eating meat is going to support the microbes that we need. So if we're eating our natural diet, we should cultivate and support our optimal microbiome. And we're seeing this in more and more people, data coming out showing that people that go on carnivore diets have massively improved microbiomes. And, saying, oh, you need vegetables, you need fiber. You don't actually. Saying that, well, when these people increase vegetables and fiber, they're coming from a processed junk food diet. Now they're having a more whole food approach, and there's an improvement. I'm not surprised, but that doesn't mean that that's the best that you can do. And that having a non-fiber diet because you're eating a lot of healthy meat, that doesn't mean that fiber in that context will actually be beneficial. And that's what we're seeing. We're not seeing that. We're seeing that people are actually benefiting and getting better microbiomes when they get rid of fiber and plants and only eat meat. And this lines up with the fact that people like the Inuit and our ancestors during the ice ages who didn't have access to plants or fiber or fruit or anything else, they made it. They didn't die. And so if the microbiome's A, important for health, and B, we can't get a healthy microbiome and thrive without plants and fiber, all those people would have died out. And I would be dead. All these other people would be dead. We have horrible gut issues. No one has horrible gut issues. People go on carnivore in order to fix their horrible gut issues, and they do. So, no, you will improve your microbiome.
How do you see dairy in terms of the inclusion of dairy in a carnivore, low carb, like low sugar diet? Do you think dairy is kind of like sugar in disguise?
Well, it has sugar in it. I mean, it has enough lactose that it will kick you out of ketosis as an adult. For kids, it won't, but up to a certain point, it will. But basically the point of weaning onto proper foods. But dairy is a bit of a gray area just because it's comes from an animal, but that it still has other things in it. But it's extremely nutritious. It has a lot of excellent nutrients. Has a lot of excellent fats, especially full fat dairy. It's an excellent source of vitamin K2, and it's like the MK7 version of K2, so it lasts longer in your system, and so it's more effective. And so there are a lot of very, very good beneficial nutrients in dairy. Hence why mammals create dairy for their babies. But at the end of the day, dairy and milk is designed to make baby mammals grow quickly. And so that's gonna send different impulses to their body, or it's gonna send the same impulse, but we want different impulses. So we just want the nutrients. We don't want to just to store energy and store fat and all that sort of stuff. Babies, you do want that, right? So it's just doing a different thing for a different time of life. And so you're gonna get the same effects from that dairy as an adult as you would as a kid, which is it's going to tell you to eat more and to grow, because it can change your hunger signals and it can increase your hunger signals. And then so you sort of want to eat voraciously. And then that energy that you're bringing in, you're storing that because your body's like, we need to keep this, we need to store this, we need to grow. And that's why the majority of what babies do is eat and sleep. Eat, sleep, and poop. That's sort of it. And that's because their body needs that. It needs those energy. It needs that growing time. And you grow when you're sleeping. And so if you do that as an adult, you could get the same effects, which is you'll eat more, you'll get more hungry, you'll overeat, and you can store fat or delay fat loss when maybe that's what you're trying to do. And it can also be pro-inflammatory. The casein proteins can be pro-inflammatory. They can, seem to be able to cause leaky gut, and people with autoimmune issues tend to have a poor time and poor outcome when they have dairy, even raw dairy, unfortunately. Now, maybe certain individuals don't, but a lot of them do, and so it's just something to be mindful of and be careful of. And certainly, if you're trying to lose weight, dairy might not be your best option. If you are going to have dairy, I still think being in ketosis is a very important thing. So I would still have less than 20 grams of total carbohydrates a day. And so you see, okay, how I can have 1 glass or 2 glasses or whatever, or this much yogurt, and that's it for a 24-hour period. You're also going to start, chasing the carb dragon, though. Like heroin addicts, they get high, and they come down there. Oh, I need to get back there. I need to get back there. I need to get back there. So it's called chasing the dragon. You do the same thing with carbohydrates. You drink some milk, and then you feel fine. I mean, it's great. Ooh, that was delicious, and it is. But then in an hour, your blood sugar went up, and now it's crashing down because your insulin went up, and now your insulin stays up. and your blood sugar crashes because the carbs went down. And now you're tired. Now you're like, oh God, I can't, like, oh, I need to go have some more milk and get more energy. And then you feel good for a while. And then you crash in an hour and you have another glass and another glass and another glass. And so now you're chasing the carb dragon again. I have milk very rarely because of exactly of that. Because I have one glass of raw milk, whatever. And then I'm feeling great. I'm like, I'm, come home from work. I'm like, want to go to the gym. Like, okay, I've got all these ambitions. I'm going to go to the gym and I'm going to work on my book and I'm going to do this. I'm going to do that. And I was like, oh, well, there's some milk. Oh, I'll just have a glass, one glass. And like in an hour, I'm literally passing out on the couch. I'm like, I can't go to the gym. I'm not going to be able to work. Like I need to go to sleep. And the old sleeping remedy back in the day used to be a warm glass of milk before bed. Could have been this time where people were predominantly in ketosis, then all of a sudden having some milk just dropped them off, and put them into like a milk coma, like a baby, And I certainly find that. So I avoid it for that purpose. But there are very good nutrients in it. Now, if you're not doing a ketogenic carnivore diet, you're having a mixed diet. Full fat dairy is probably a great idea. It's gonna give you a lot of nutrients you're probably lacking because you're eating a whole bunch of other stuff instead of what you should be eating. And so it depends on the context. But if you're talking about ideal, then no, it's probably not ideal. Things like butter, ghee, they've stripped out most of the casein, most of the lactose, and so it's just more of just the condensed fat, and that's healthy. And most people do well on that, but with autoimmune issues, you should always be mindful of that. But other people don't seem to have a problem with that. So I would just keep those ideas in mind.
That's fascinating about milk. I mean, I think that most people, if they try to drink milk, they'll be like, yeah, I have the same thing as Dr. Chaffee. I have a bit of a nap after. So final question for you. You mentioned B12. People that are low in B12, they tend to have poor brain function. What is the optimal range for B12?
So there are different studies, but the thing to remember is that the reference ranges are useless. They are based on averages. And so every country has different averages, every reference ranges. Every lab in every country has different averages. There are labs here in Perth that have different labs in Perth. They all have completely different reference ranges. And then the parent companies that own this lab in Perth also own a different lab in Melbourne. They have different reference ranges. So it's completely ridiculous. And so saying it's like all of a sudden I have excessive amounts of B12 in Perth, but then I fly to Melbourne. It's, oh no, now it's fine. Okay, well, so now I'm not in a hypervitaminosis state. Now I'm not causing harm just because I moved locations. That's insane. And people argue that. So, well, but basically where you are, that matters for your nutrients. No, it doesn't. Like no matter where you are on this planet, you need a certain amount of B12 and D3 and proteins, etc. So that looking at just an average is stupid. And also, you have to use the average for the healthy population in that city, whereas every single lab in that city are using different reference ranges, and they can be wildly different. To give an example, there's 3 labs here in Perth. One has a range of 140 to 650 picomoles per liter for B12. Another one is 150 to 1,000. And another one is just anything over 330 is fine. It's like, okay, so if you have 200, you're going to go to 2 of these labs and your doctor's going to say, oh yeah, you're fine. Yeah, it's in the range. Oh, it's on the lower end of the range, but you're in the range. That's fine. But then you go to this other lab where anything under 330 is a deficiency. And like, oh, hey, hold on a second. Now you're deficient. Well, which one is it? Right? Because you're either deficient or you're not. I mean, that's an objective reality. Right? And so, you need to know that. And so what if you have 700? Well, at one lab, you're going to be too high. And another lab, that goes up to 1,000, no, it's fine. And the other one just says, anything over 330, it's fine. Okay, so which one is it? You go to one lab and it's too high, and your doctor says, my God, you have to stop eating all this nutritious meat. You got to stop all these nutrients, And the other 2 is like, yeah, it's fine. So which one is it? Well, they're actually all wrong because you're actually still low. Because studies have shown that optimal ranges of B12 are between 800 and 1,200 picomoles per liter. And so we are making objective, prescriptive decisions as doctors and patients, saying, eat this, don't eat that, stop eating this, add more of that, or add in supplements based on completely arbitrary figures. So you have a level that says, oh, it's 400. Okay, well, actually, all of those 3 labs would say that that's normal, that that's fine. But in Japan, anything below 500 is considered a deficiency. At least in some of the studies that I've looked at where they referenced them back in 1988. There's a study that I found referencing that. Below 500, they considered a deficiency. And that makes a lot more sense because there's a study out of Oxford that actually showed in 2008 that even when you're in the 400s, and certainly below that people were actually getting demyelination of their axons. They actually didn't have enough B12 to maintain, let alone build new myelination on their axons in their brain. So they actually were getting brain shrinkage. Their brain was shrinking by 2.5% to 5.5% every 5 years. So you can't say that that's a sufficiency, that that's a normal amount. If it's so low that it's such a critical deficiency that you're actually getting brain damage. So everything's off. So you can't make objective decisions with arbitrary figures. If you were an accountant and you use just arbitrary sums, you're going to jail. You're going to be in prison, right? If you're an architect or an engineer and you're using arbitrary metrics and measurements to say this is how we should build this bridge, you're going to have bridges collapsing, you have buildings falling down. And when you're doing that in medicine with biomarkers, blood markers, and nutrient levels, you're gonna have people getting sick and potentially even getting very seriously sick. So the reference ranges that I use are based on those studies, and that's between 800 and 1200 picomoles per liter. And I would consider anything below 500 a critical deficiency that you should start supplementing and even get a B12 shot if it's below that.
Dr. Chaffee, I hope that gave people a lot of hope to just quit the sugar, eat more meat, to fix their health and their brain. Thank you so much for your time.
You're very welcome. Thank you for having me.
I hope you love this episode. Check out this one with Dr. Andrew Kutnick. It is all about a new low-carb study proving you do not need to eat carbohydrates. I'll see you guys next week.